This is Owen's project. My topic is create dilation images of polygons in the coordinate plane given a scale factor. In this type of problems, they will just usually give you a shape in a coordinate plane, of course, and give you a center and a scale factor, and they want you to correctly create a similar image of the polygon around the center with the scale factor. I will explain the concept of scale factor here. Scale factor is just the ratio you want the dilated image to be relative to the previous image before the dilation. So if I have a scale factor of 3, I want the new image to be 3 times as big as the old one. If I have a scale factor of 0.5, say, we will want the new image to be half the size of the previous one. So first we'll jump into a problem here made by myself. We just have to create a dilated image of this triangle here with the center 3, 2 and the scale factor of 2. So first, because this is an easy problem and the center is just a vertex of the triangle, we just have to extend the size of the triangle. So the first side AB here, it's 7 and AC is 4. And to make a scale factor of 2, we time 2 to each of those sides. 7 times 2 is 40 and 4 times 2 is 8. So this is what we got after the multiplication. So here I will in depth explain the concept of center with the previous result. The center is essentially the point which you relatively dilate all the points from. So when you think of dilation, you just think of like making the shape bigger or smaller. Actually, in geometry, dilation is about moving the vertices relative to the center. It's about changing the distance between the vertex and the center based on the scale factor. This is going to be a lot more clear after we get through our next problem. In this one, we'll have to dilate the triangle ABC at around the center 5, 3 with a factor of 2. So this one, the center is not a vertex of the triangle, and the triangle is not a right triangle anymore. So it becomes slightly more complicated. First, we'll look for the distance between each vertex and the center. So during the dilation, there's nothing to do with the size. Just ignore the size. Only thing matters is the vertexes and the center. The distance is 2 blocks up and 1 block over to the right. Now we time it with the scale factor, which is give us 4 and 2. We put that into the dilation, and this is the dilated point of the A point. We do the same thing for the other 2 points. First, the C point is 8 blocks to the right and 4 blocks up. We time that with the scale factor, and this gives the second dilated point. Exact same thing for the third point, which is 6 blocks up and 4 blocks over. The little number is there. We times that with the scale factor and we get the dilated B point. Now we have all of our vertices, we connect them, and we can see the triangle here. This is a list of the final steps of doing this dilation thing, wrap up. So you find the distance between each vertex and the center, times that with the scale factor, and add the result onto the vertex. I mean, the centers. Sorry, it should be the center. The center's xy coordinate, and the distance is just the xy difference between the center and the vertex. So might want to pause here. Well, moving on, next section. So now we're seeing some different kinds of questions and harder problems. I'm not sure if I don't think this is gonna be on the test or anything, and I don't even think this belongs to my area, to my topic, but don't want to just see it on the test and realize you have no idea how to do it. So I'm just putting this here. In those questions, you're given the scale factor and the point before the dilation and after the dilation, and you have to find the center of dilation. So the first thing you want to do is still find the distance between the dilated point and the original point. In this one, we have it turned from 0 to 0 to 5, 3. It got a positive 5 to the x value and a positive 3 to the y value. And I made an equation here. Just note that x and y, they are not coordinates, they are variables here. So what you did to the dilation of the point is actually just doubling in this case, doubling the distance between the point and the center. So the point and the distance between the point and the center is x here, and 2x means the distance between the center and the dilated point. So 2x minus x is 5 here, and so 5 is 1x, which is the distance between the center and the point we are dilating. It would do the same thing to the y value here. We'll get 5 and 3. So we just subtract 5 and 3 from the undilated point, from the original point, from the 0, 0. And we get -5, -3 at that point.